In this live session, we assume that you have went through the test out content week 6 10.1 all the way to 11.5, and this covers a lot of concept standards and even labs. So we highly recommend that if you're taking this course from our program, you should really finish the hands-on labs and also go over the videos to understand certain things in a more detailed way. When it comes to wireless management, as a network engineer or a junior network engineer or even a sysadmin, you're given access to control some of the wireless equipments. And this could be a captive portal type of solutions where somebody from different companies come to your building and they're offering, let's say, some type of presentation, and they need to connect to the Wi-Fi. So you may have a guest network to manage and how they are going to connect, and then internally you will have your private Wi-Fi network for your employees, and then you will be managing that, because in that some people can just come to your building and connect a malicious devices to your network and start scanning things. So how would you protect that? So this is where understanding the wireless technologies and how these different type of devices works, security, and all that type of implementation is definitely something that you're going to get a ticket once a while. Now in reality, you don't get a lot of tickets from Wi-Fi related issues, because once you have equipment set up and everything is running, consider this to be like your home network in your home. Your wireless don't go down every single day. If it is going down, then of course you're having some kind of issue, maybe with one or two access points. There's some issue going on, and then you'll have to either reset it or replace it. In most cases, you don't do a lot of work is not given to engineers in this area unless you're working in some type of conventions. Now that's another story, that you may go to a convention which, let's say, they have 10,000 people, and that 10,000 people, out of that 10,000, so many people are trying to connect to the Wi-Fi. And if you're one of those type of engineers who are doing this on the go, like you go to a different places, you set up things really quickly, and then of course you need to understand how Wi-Fi works very much in detail. But going through these videos, these labs right here, and then the session that you're going to listen in this video is really going to round it up for you, at least at the Network Plus level. Of course, this is something we're going to discuss a little bit later on in more detail, but in this course, Network Plus, you're going to understand a very good basics, and you will be able to answer some questions in interview, and you will have understanding when you start working in real world companies. Thank you for watching, and make sure to watch this whole session fully and take some notes. And if you have any questions, drop it in the comment or in the course section. Thank you.
Hello and welcome to week 6 module. In this module, we are gonna discuss about the concepts of wireless LAN and wide area networks. So before I proceed, I just want to make you sure that this wireless LAN we will not gonna learn in the CCNA, because wireless technology itself is a complete chapter and a complete certification done by the CCNA level. Whereas the wide area networks we are gonna cover in the CCNA as well. So in this session, I'm just going to discuss about the very basic concepts of wide area networks. So the agenda is same. I will touch upon some flyby concepts of these two, and then I will perform some labs, and if required, we will touch upon some new concepts as well. So what is wireless? As the name implies, that if we are not going to use any kind of cabling to connect our devices, we need some kind of infrastructure for that. So for that we need these access points. So these things are known as the access points or wireless access points. So basically the concept and the idea is same. If we have these two computers, two PCs, and they want to communicate or share the information between each other, we remember from our previous knowledge that we used to run some cable from computer all the way to the switch, and then from switch to the another PC, and all information pass on using these cables. So whatever the information, they will go across these cables. But this time we do not need these cables. So what is the solution for that? The solution is that we are going to install one access point that will be connected with the switch, okay, and then switch may be then connected with the router, and then router will be connected with our service provider. So we have internet connectivity, but this time we are going to access this access point with the help of wireless. So in case if this computer wants to communicate with this computer, whatever the information he wants to send, it will go through the wireless access point and to this computer. So the medium we are going to use is air. Okay. So sometime you come up with some vocabularies. Those are like hotspot. Somebody is saying kindly connect with my hotspot. What does it mean? It means this is the same thing like access point, but this term basically used when we are going to use these kind of access points in a public environment, like in we have the airports, or maybe we are sitting in a hotel environment, or maybe we are sitting in a cafe. So they give us this facility, could be free or maybe you need to pay. So for that they use these terms hotspot. So you're gonna connect your laptop with these hotspots to access the internet connection. Then we have some another terms being used in wireless technology. Those are ad hoc, BSS, and ESS. Let's discuss about it one by one. So what is ad hoc services? In some cases we do not have access point. Let's suppose we do not have access point, but this computer wants to share information with this computer. So what is the solution? The solution is every computer has kind of some infrared technologies like Bluetooth. Okay, they will enable it, and even the Wi-Fi itself as well, with the help of Wi-Fi as well. And this computer also having like Bluetooth or Wi-Fi technology enabled, and they can make this enable, and then with the help of sharing this information with each other with some passphrase, they can share the resources. So basically there is no access point in between to share the information. So the information that is shared without access point is known as ad hoc, and sometimes it is also known as IBSS, which stands for Independent Basic Service Set. So it means without basic service set. So opposed to independent basic service set, we have basic service set. And what basic service set is? We are having access point between these devices. So if they want to share the resources, if this STA, which stands for station device, want to send information to this device, it will go through the access point. Okay, so this is known as basic service set. Then we have ESS, which stands for extended service set. It is nothing if we are using more than one access point in our net infrastructure. This is known as ESS. As you can see here, we have client laptop here, another client laptop here. If this wants to communicate with this laptop, it has to go through this one access point. It will touch the router, and then router will pass information to this another access point, and this is how information will be sent back and forth. So another term that is used in wireless infrastructure is called seamless or seamless roaming or just the roaming. And what does that mean? So basically, uh, in a seamless roaming, what happens? You have this one STA device or the laptop, okay, and you're sitting in one channel. This is known as channel 1. Okay, and this STA device is connected with the access point with the SSID, which name is Huawei. Okay, let's say this is the name, or you can say the name as just JSS. This is the name of our access point which we are connected with. Okay, so you have come across with this situation as well. You are sitting in one room and then you roam around, you go somewhere far from that access point, but still you are connected with the same SSID. This is thing known as seamless roaming. So the idea behind that is, for example, this is room 1 and this is room 2, that is very far from room 1, but this is your laptop. You are connected with this access point, but as you go across and sit in this room 2, automatically you will be connected with this access point. Okay, but you will not aware, and because there no service disruption, um, there will be no any kind of disconnection. Okay, and you will be seamlessly connected with this another access point with the same SSID. Later on I will show you why we need this channel 1 here and channel 6 here, but these things you need to take into account. So ESS, if I give you the definition, if you are using wireless network while traveling, you are on an ESS. Okay, so these are extended service set, and we know from our previous knowledge ESS is used when we are using multiple access points. Okay, such network use multiple access point to create an overlapping areas of coverage. As you can see, this area is overlapping and it should be like 10 to 15% overlapping involved. This is where your the migration process is happening from one access point to another access point, and that this cell, this area, this circle is basically known as the cells. So these are the terms, these are vocabularies you need to understand for your production as well as for your exam point of view. Then SSID, service set identifiers, is nothing, just the name of your access point. And you might be familiar with this thing because if you are using internet at your home, of course on the Wi-Fi setting you will see multiple names of your of the internet connections. Like one you are using maybe is written with a home net, and this belongs to you. So that thing is known as the SSID, service set identifiers. A Wi-Fi network SSID is a technical term for its network name. For example, if you see a sign telling you to join a network with an SSID of airport Wi-Fi, you just need to pull up the list of the wireless network nearby and join the airport Wi-Fi net. That's it. Okay, so designing a wireless coverage. This is also one of very important slide. I do remember in my old days when I was configuring wireless coverage for my hotel environment, and we have like 8 floors. Okay, so what I used to do, this is the floor, let's say, and these are the rooms. I had to configure or install those access points on the ceiling in such a fashion that, for example, if I install that access point here, at least this access point should have a coverage to this room and this room. Then I need to install that access point, another one here, somewhere here, so it will cover not only overlap, but it will cover the this room as well. So this is how, because at that time we had no these kind of things like this ICAHOW. It's a site survey tool, and this is like a very good tool. If you want to learn more about it, you can just Google it or go to the YouTube, and they will show you the method how you can perform site survey. So what site survey is, basically, you will carry a laptop, okay, with ICAHOW gadgets on top of that laptop you will be carry, and then you will just walk in the room, then you will come out, then you will walk in the floor, then you will go inside the room. Then this is how you will go one by one, okay, all the way back you will from where you started. So this is how, this your software will automatically guide you where you gonna install your access point. Maybe they will look at this area, somewhere this area, somewhere here, somewhere here, somewhere here. So it will not only give you a good guess where you're gonna install these access point, but how many access point you're gonna install. So it is up to you as well. If you want to give a good coverage to these all rooms, you should have like in this case, as you can see, 1 2 3 4 5 6 7 8 somewhere, okay, 8 access points, but it could be more than 8 as well, because you want to cover these all rooms with the coverage, okay. So the first thing that comes under wireless deployment is the conduct site survey. So this is the tool that will be used. If I will very quickly take you to this website, and I can show you. As you can see, I have already opened this one. So this is the name of the website, icahow.com. And as you can see, this guy is just checking about the frequencies. First of all, what kind of frequencies it can use. Once it has figured out, then it will carry this laptop, and then these are the things that is he is having, like these are the gadgets, okay. And then as you can see, as you can clearly see, he's suffering here because there are so many things he's carrying. So ICAHOW came up with the idea, so he will carry only this laptop. So instead of carrying these multiple Wi-Fi devices, okay, as you can see, these are Wi-Fi devices, they came up with the idea with this gadget. They will he will just like back carry this one, and this this device will be connected with the this laptop, and now this guy will be walk in the floor or the area he want to do a site survey, and then he can go one by one, and the process will guide you through how to do the site survey basically. So this is a very good tool. You can further dig deep if you want to. If you are interested, you can learn about ICAHOW technology, and I have been using this as well for my projects. Then another important thing is minimizing SSID. And what does it mean? It means let's suppose if we have this office, okay, and we want, or we have a plan to install multiple access points in our office or in organization. So what you gonna do? You will not do like this. For example, you have one access point here, and you will name this access point is like AP1. Then you will figure out that another access point you need to install here with the name A2, another access point with the name A3, another access point here with the name A4, and so on and on. Okay, this is not a good uh, by the way, mechanism to use deploy these access points in your organization. Why? Every time you roam around, you need to provide a new credential for this access point, because this is not a seamless roaming, by the way. So it is saying minimize SSIDs. Minimizing SSID means you have to give them name all same, like A1 here, A1 here, A1 here, and with the same password. So when the guy will roam around, it will be a seamless roaming. This access point will take over without noticing anything, or without having this guy noticed. Okay, so this is called minimize SSID. So in some organization you also used for the guest as well. So what you can do, in the same access point, you can create one SSID with name like JSS, and with the same access point you can create another SSID for the guests with the name JSS underscore guest. Okay, so you could have only two SSIDs. You cannot go beyond that, otherwise the logic will fall apart. Another important aspect is the channel design. That is also a very important concept. So as you can see here, if you have very good visuals, you can see there is the boundary behind these circles. So basically these are the floor plans, and somebody did like access point here. This is the access point, this is another access point, this is another one, and so on. We have like 8 access points here. Okay, but they haven't put these access points on the same channel. As you can see, this access point is on channel 11, this one is channel 1, this one is channel 6, and then again it starts from channel 11, 6 and 1, then 11 and 6. Why? Because if you will keep this channel with channel 11, means this channel is in channel 11 and this one access point is also in channel 11, there will be issues. There will be they will be working on a same frequency, and when both frequencies are same, you could have so many issues. Okay, you could have collisions, you could have service degradation. So always keep it in mind to keep these channels on a separate domain, or on separate the number. Okay, like channel 11, 1 and 6, 11, 6, 1. This is how you are gaining also another thing that is called overlapping. As you can see, it is overlapping. Okay, if you will use the same channel, the chances are they will not overlap, and you will not get any kind of seamless roaming. And it is mentioned here 15 to 20% overlap is also required, because when you move your laptop from one channel to another channel, this another channel should take this automatically. uh, he will get this uh, if this guy is roaming, for example, he is somewhere here. Okay, now as he's moving somewhere here, this channel will take over. So this is known as seamless roaming. So as you can see here, when we are working with a 2.4 gigahertz cellular coverage, this is how the channel should be configured. But when you are on 5 giga cellular coverage, this is how channel should be configured. But these are things a little bit advanced, but you should have the idea how to configure the channels, and we will do a lab for those as well. Now this thing will be very familiar to you if we have studied the switching, and we have already done, and we remember that there, if we are using half duplex, okay, and we know half duplex we have collisions, so many collisions. To avoid those collisions or to detect those collisions, we use the same kind of technology but with the D, CSMA /CD. Carrier sense multiple access with collision detection. But in case of air or in case of wireless, we use CSMA/CA. The concept is 100% symmetrical, but only the difference is with the A. Instead of detection, it will do just the avoidance. Okay. So as it is mentioned, the concept of collision domain applies also in a wireless network, because the radio signals traverse a shared medium, because they are sharing this air medium, which is shared medium, which is the Wi-Fi radio spectrum. Sender send RTS, which is request to send, means this sender will send first of all RTS, okay, to check whether the path is clear now. Okay, frame and responder will send the CTS. So the responder will send the CTS. It will tell to this requester that the path is clear and you are allowed to send the information. So after that, final acknowledgement will be sent from the receiver. So once it will receive the data, it will send the acknowledgement back to the sender. So that's why then another system, if this system wants to send, now the acknowledgement has been already sent, it means the path is clear. Now this PC3 is ready to send the information or the request. So the concept is almost symmetrical that we have discussed in a CSMA/CD. So these are things are same like carrier sense multiple access with the collision avoidance. Everybody will sense the carrier, and then everybody has same access to send the information, and if there is any kind of collision, they need to avoid those collisions. And then we have some wireless standards, and if we been using a wireless router access points or home routers, we are very familiar that these things comes up there as well, like 802.11a, b, g, n standards, and these are like somehow old standards. Okay, so this is like these are known as 802.11 standards. It is defined by IEEE. So the years they released in back in 1999. Okay, so this is very old. And 802.11b also came in the same release, but the difference was it works on 5 gigahertz, and 802.11b works at 2.4 gigahertz with 11 Mbps of speed, and 5 gigahertz with a 54 Mbps of speed. Then they came up with 802.11g, that is also very similar to this one. So it means 11g is back compatible with 11b. Okay, so they work on the same frequency, which is 2.4 gigahertz, but the only difference is this B is have maximum data rate is at 11 Mbps, while the 11G has 54 Mbps, means better speed. Then we have 802.11n, that is compatible with these both. Okay, because it works at 2.4 gigahertz as well as 5 gigahertz. But the most beneficial part is 600 Mbps, means much more better speed as compared to these one. Then the time moved on, and then the engineers, they came up with another standard, which is 11AC with the 1.3 gigabits per second and 10 to 12 gigabits per second, which is in year 2019. So this is the latest one. So you have to remember these standards and the frequencies and the maximum data rate, because these are very common interview questions, by the way. Of course, when we are using wireless access points, we need to have kind of privacy. Okay, when we are going to connect with our access point, it isn't like that. If I have a home router and I'm trying to connect with it, okay, this is my router, okay, and I can connect. And if it is not protected, the chances are there are so many other people around you. For example, your neighbors or someone is sitting outside your home, they can also connect with your access point and they are using your bandwidth. Okay, so for that we need a privacy, we need a security. For that, wireless LAN, they came up with the standards, these privacy standards. The first one is WAP. Okay, and this is wired equivalent privacy. This is very basic encryption. Basically it use size of 40-bit encryption. Okay, because that was the first standard came into being, so that's why it was very small and it has no any strong authentication. Its keys are breakable keys. It is not a scalable solution. The remedy was used to do MAC filters and SSID cloaking, to mitigate the problem that it had. But again, it was old technology, and it is being hacked. So basically, what happened in WAP, if we have this access point here, let's say this is access point, and we have this laptop which is configured with a WAP authentication. When it wants to authenticate with this access point, this access point basically send the packet which contains the password. Okay, which contains a password. If the hacker is sitting here and if he or she is tapping this information, he can clearly see this password. Okay, and another drawback was that let's say this this laptop previously connected with this access point, but somehow it is disconnected again this service. Now it wants to connect again or authenticate again uh, the password should be remembered, but access point will send the password again back to this laptop. So this is how the hackers, they are very clever. They will, what they will do, they will disconnect this connection between these two devices. Why? So this laptop will go for another attempt for the authentication, and meanwhile this hacker will interrupt in between and will get this packet information, and this packet information we know is having this password information, and this is how they're gonna crack and can use the same information to access this access point. So that is the reason the WAP has already been obsolete, and if you go inside your access point, the newest access point, you will see WAP is no more there, because this is very weak encryption. So I will skip this one for the time being, and I will jump to the WPA, which is known as Wi-Fi protected access. This is a bit you can say the new concept they came up with. This is a standardized protocol. It has improved encryption, strong authentication. It used like leap, peep, and there is another thing they call it TKIP, which is temporal key integration protocol. Okay, and TKIP basically as we know, this is web use 40-bit, but in TKIP they made it more advanced, and they used it like 64 all the way to 128-bit of encryption. Okay, so the encryption or the block cipher or the block size has been improved as compared to WEP, but it is also a long gone, because it also came up with some flaws, some issues, some errors. So that's why they had to remove this option as well. So they came up with another idea with the same like with the same WPA. They came up with a WPA2. It has, instead of TKIP, they use AES, which stand for Advanced Encryption Standard, which by the way use 128, 192 and 256 bit of size for the encryption. It has a better authentication and dynamic key management. That was static, by the way, as you can see, the static. So it is dynamic key management. It is sending keys dynamically. So even if the attacker or the hacker is sitting in between, he will not guess these password, by the way. So this is a very strong authentication, and that is being used these days. Let's move further. Another concept under wireless is known as wireless LAN controller. And what is wireless LAN controller? Is used in combination with the lightweight access point, which is known as LWAP protocol, to manage the lightweight access point in a large quantities by the network administrator or network operation center. The wireless LAN controller is a part of data plane with the Cisco wireless model. So before I go to the WLC, what is it? I just give you another example. So Cisco has two kind of architecture under WLC. One is distributed architecture, another one is centralized architecture. So what happens in distributed Wi-Fi architecture? As you can see from the diagram, we have how many access points? Only 1 and 2. Do you think we need some kind of another single pane of glass or wireless LAN controllers to manage these two devices? No, because there is even no admin overhead. If I am working as administrator, I just go into this access point console or GUI. I will configure this access point. I will go to this access point. I will configure this access point, and that's it. Even if I have like 5 to 6 access points, I will go one by one. I will configure all the configuration like SSID, the password, channels, okay, and the frequencies, and then I will go here, and because 5 or 6 access points is not a big deal. But what in case you have like thousands of access points? Like in my case, we have like 12 floors in my hotel environment, and every floor equipped with almost 10 access points. So you can multiply 10 with the 12 and you can come up with like 120 access points, which is also a very big deal. 120 access points. If the manager will ask me to go to configure 120 access points, what I will do? I think it will take like 4 to 5 days to configuring these access points one by one. So what is the solution and what is the remedy for that? So the solution is wireless LAN controller. I will configure, let's say we have 1000 access points. I will configure on top of that one wireless controller, and I will just do configuration on this device. That's it. Like SSID, frequency, channels, the passwords, encryption, everything will be replicate to these access points. And what that infrastructure is known as, that is known as centralized architecture, which is on the next slide. So this is our centralized architecture. So we have wireless LAN controllers, and then we have lightweight access points, which basically gonna grab these configuration from wireless LAN controllers, and then maybe system admin is sitting here, okay, somewhere here, and he's just concerned with wireless LAN controllers. Whatever the configuration will be done on this WLC will be replicated on these other lightweight access points. Another very important concept or the term that is being used in a wireless LAN controller is called CAPWAP. As you can see, these CAPWAP just like VPN tunnels. A kind of, it is not like VPN, but a kind of concept you can take, So basically, whatever the information I configured as a system admin to this wireless LAN controller, it is gonna go through what ways? Okay, So basically wireless LAN controller and lightweight access points, the language of love or the language of communication is using the CAPWAP. So this is how they're gonna know each other about the information. So whatever the information wireless LAN controller is gonna pass to access point is gonna go through CAPWAP, okay, which stand for control and provisioning of wireless access point. So if you are interested into read about this thing, is a protocol which makes it possible to bind a lightweight access point with a wireless LAN controller. The CAPWAP protocols encapsulate the traffic between the lightweight access point and WLC, a virtual tunnel called CAPWAL. As you can see, this is a virtual tunnel is created. All traffic from access point to the WLC travel through this tunnel. So whatever the information that is coming, it will travel through this CAPWAP and will go to all the way to the WLC. Okay. So all traffic from the access points terminate to the WLC controller and then diverted from the controller to the wired network. Then we have another wired network, like this is wired. It will go here, and then we have like internet here or some router here which is connected with our ISP, okay, which is nothing but the cloud. Okay, so whatever the information, it will come from here, it will go to the WLC, and then we will use these CAPWAPs to send this information to the requester. How WLC controllers look like, and they have some ports just like in the switches or the routers. WLC is totally a unique device which is having a totally different ports. Some of the ports like common, but some ports are a little bit different. So controller ports are the physical ports of the device as shown in the picture. The following are the most important ports basically. So I have mentioned here, the first thing is service port. You can correlate it with this one. This thing is the service port. And what is it used for? Initial boot function. We familiar that in the routers we have boot function capabilities. So this is used for the boot function, system recovery, out of band management. If you want to configure the controller GUI, okay, we just can use RJ45 Ethernet cable. We can connect with the computer, okay, and this device have some kind of IP through which we can access the GUI of this device. So this is the service port is used for. Then we have this RP port. If it is mentioned here, yes, this is a redundancy port. You can correlate with this one. This port is used to connect another control for redundant operation, and redundancy is beneficial for any organization. What if this device goes down? What will happen? We must have another same device ready, okay, which have one RP port which will be connected with this RP port. So this is the concept, just like uplink port. So not only the heartbeat of this, because if this will down, how this thing will know that this thing is down? Okay, it will be sent some kind of heartbeat through this uplink port. So once this is down, it will come up. So whatever the devices are connected with these two as a redundancy, before they were using this as a main controller, but this time it is down. Now they will go through this wireless LAN controller. So the redundancy is required and is a very good feature we use in an organization. So RB port is basically is concerned with that option. Then we have some distribution ports, and these are just like SFP ports we have learned in our earlier modules, or Ethernet ports or fiber ports, which are these SFP distribution system ports. It is saying that in switch port in a trunk mode, basically this device will be connected with some switches, let's say some switch. Okay, then these switches will have some kind of VLAN information, like VLAN 1, 10, 20. Okay, so we can configure this as a trunk port as well, and you are familiar at this point what trunk is. Also another thing, 4500 series control has 4 distribution ports, but 5500 series controllers have 8 distribution ports. As you can count it, 1, 2, 3, 4, 5, 6, 7, 8, and the name, if 5506 something like, means this is from the 5500 series, which is having total 8 ports. Another thing is this console port as well, and you know what console port is, so I don't need to explain here. So let's do a little demo on a wireless, and through packet tracer I will walk you through one by one the steps. Basically we will do we will configure 2 access points. We will give the same SSID, which with the name like JSS. We will use WPA2 authentication, and we will do the password. Okay, we will put this device on a channel 1. Okay, and the same configuration will be here, the same SSID, same WPA2 password, but we talked about the channel. We will keep this on a channel number 6. Why? So we should have kind of overlapping. Okay, then we will have one laptop which will be connected with this router. Then we will shut down this router to see the connectivity, that seamlessly it will this router will take over. Since we do not have anything like we do roaming, so that's the reason I'm going to switch this off. So let's very quickly jump onto the lab, and we will do the Cisco Packet Tracer lab. So we are here, and at this time you might be familiar with the Cisco Packet Tracer a little bit, because I have already gone through many examples. So in this lab we're gonna do a lab on a wireless. So what you can do, click on these devices, or just a minute, you need to go under network devices, and then we have these things. If you mouse over on that, it's written wireless devices. So click on that. Then we have so many things here, like Meraki based routers, belongs to Cisco. Wireless LAN controllers, these are the wireless LAN controls, these are the home router, these are the access points. So for this lab, let's use this home router. Okay, just give it name like R1, and very quickly let's what we are gonna configure, like SSID. we will make it like JSS. Encryption, we're gonna use WPA2. The password we're gonna use let's keep it simple, like 1 2 3 4 5 6 7 8. And the channel number, we will keep this one on a 1. So just copy this one. Okay, then place another router and give it a name like R2, and with the same configuration but channel number 6. So just keep it here. So this is the information we want to need. And for the IP that will be allocated to our laptop, whatever the default is, we will keep it as it is. Okay, so you need to go into the computer and pick one wireless laptop. This is the laptop. Okay, so first thing first, let's configure the laptop first. Okay, so click on the laptop. Just zoom in. As you can see that its power is on and it is currently using fast Ethernet. Okay, we do not want. If you will drag and drop, you will see it will give you error because we need to power it off first of all. So from here, just click on the button and it's power off, and drag and drop here because we're gonna use wireless. We want to install a Wi-Fi device on that, or adapter, which is this WPC300N, and you can see here as well. So what you can do, just drag and drop here. Okay, so this Linksys WC300N has been installed. Now click on the power and the device's laptop is working. So as you can see, it is directly connected, but we do not want. Later on we will change this one. So now you need to go under desktop, and you can see we have the option PC wireless. When you click that one, you will get something like that. It means your wireless adapter is connected and it is giving a good signal strength. Just close this one. This part has been done. Later on we will connect it with the routers, but we need to configure the router first. So what you need to do, first click on this router and zoom it in and switch it off. It has been switched off. Okay, now it is connected with this one. So click on this one. Basically, it is not connected, but it is showing my wireless adapter has detected that there is a wireless access point. So click on this wireless home router. You need to go under GUI, which is graphical user interface. Click on that one. And if you are familiar with the Linksys, now the Linksys, Cisco has owned the Linksys, by the way. But if you have any idea with the Linksys configuring these devices, if you will see these color scheme, you will quickly guess that this belongs to the Linksys, by the way. So we need to configure these SSID security thing. So first thing first, you need to go into the wireless. Okay, and as you can see, the network mode is auto. That network name SSID, and we know that what SSID we want to put. We want to put JSS. Okay, the SSID is broadcast is enabled standard channel The channel, we promise that we will keep it on a 1. Okay, and then keep this auto bandwidth, and that's it. Then we need to go into the security. Click on this one, click this one, and we said that we want to enable WPA2. Okay, so keep it WPA2 personal. So click on that. We have to select the encryption which is the strongest one, which is AES. Select this one. The password we will keep 1 2 3 4 5 6 7 8, and from bottom just save the settings. So very quickly just see if our configuration is working or fine. Click on here, and I forgot to save this one, sorry for that. So click here, SSID is JSS, channel is the first one, and do the save setting. So click on a save setting. So now it has been saved. Go to the wireless security again. We can see our AES and the passphrase is there. If I go back, and we can see the things are working fine, and that's it. And just close this one, come to this laptop, click on this PC wireless, click on this connect tab, and refresh this one. As you can see, the JSS job skill share SSID is visible. Okay, but I don't want to connect right now because I want to enable the another router as well with the same configuration, and then I will connect with this one. So what we can do for the time being, come here physical and just switch it off. So I don't want any kind of connectivity right now. So click on this router, zoom it in and switch it on first of all. Then go to the GUI and perform the same method that we did with the router one. So we need to go into the wireless. Okay, from here we need to keep it auto, and the SSID should be same, JSS. SSID broadcast is enabled, channel bandwidth and channel. You remember what channel we need to put it at? Channel number 6. Then come down and save the settings. Then we need to go into the wireless security, and we need to enable the WPA2 personal, which is AES, as we can remember that TKIP belong to just WPA. Okay, so we want to keep it AES, which is strongest one, and the passphrase is the same, 1 2 3 4 5 6 7 8. And from here just save the settings. Okay, and just double check the configuration. It is JSS, channel is 6, wireless security is there. Okay, that's fine. So just switch it off again, because we want this laptop to connect with this one. Okay, so you need to go inside GUI. As you can see, it need to be powered on. So powered it on and go into GUI. Under setup, the basic setting, you see automatic configuration for the DHCP, and we know that this access point will work as the DHCP as well. So you can see it is using 192.168.1.1. okay, the IP address for this access point itself, which is handing over the IPs from 100 all the way to 50. So it means IP address ranges are 192.168.1.100 all the way to 149. So DHCP is currently enabled. Okay, so things are pretty much fine on this one, and we need to check the IP configuration there as well on this router as well. So click on this one, turn it on, go into GUI, and as you can see the same similar information is there as well, 1.1. Now we need to connect this laptop with this router. So click on this one, go into PC wireless, click on the connect and click on the refresh. So as you can see, it's supposed to be one, by the way, because this is a simulation environment. That's the reason we are seeing these two. As you can see, one is on a channel number 6 and another one is on a channel number 1. If you here you can see this is channel number 6 and channel number 1. But since we are using the same SSID, there shouldn't be like this. It should be like only JSS. Okay, but no problem, we know that we have configured channel 1 for this one. So we will select this one, click on the connect, and we know that we are using WPA2 personal and the passphrase is 1 2 3 4 5 6 7 8. So before I go do connect, I just want to make the confirmation that it has no any kind of IPs. So click on IP config and you can see nothing is going on. Okay, so this is wireless LAN 0 connection. If I try to ping this one router, let's say 192.168.0.1, which I can ping, which it shouldn't, by the way, this is a glitch. So I want to release this one. Okay, and I need to go into this laptop, go into the configuration, or just close this one, click on this PC wireless, connect, refresh. As you can see, it is not connected. Okay, we have signal strength but it is not connected. So clicked on refresh, select this JSS, this one channel 1, connect, and we need to put on the passphrase. Let's give a wrong passphrase, 7865432 and connect. As you can see, there is no association with the access point because we gave a wrong passphrase. So this time let's click on this one and click on the connect, refresh this one, click on this one, the one with the this one, connect, and this time we will put the right password, which is 1 2 3 4 5 6 7 8, and click on a connect. Okay, when we will come here, I will try ipconfig/release, ipconfig/renew. As you can see, the IP has been given. Okay, for the this wireless access point. If I try to ping my router, the default gateway, as you can see, I can ping this router. So to show you that how seamlessly this router will take over. Okay, what I can do, just I need to double check that it is working. Yeah, as you can see, now it has changed to 0.1. Just a minute, let me check. This is also 0.1. Okay, no problem. So these both are using what IP is scheme 192.168.0.x network. So both routers are working on 192.168.0 network. So this router will hand over the same range, and when this router will be down, this router will take over and will give the same IP. Okay, so what we will do, we will do a continuous ping, and you know how we will do the continuous ping with -t 192.168.0.1. So as you can see, the ping is going on. We will come here and we will switch this off and just wait, and as you can see, it very quickly connected to this router. But let's see what it made affect. Just only one request timeout, so it means we were using internet connectivity, and as we moved from this router to this router, we did roaming seamlessly. It just moved us from this router to this router. Okay, so this is the concept of roaming, seamless roaming. I hope you got the idea how SSID, because we have gone through these all configurations, and how this laptop automatically jumped over from this router to this router. As this went down, as this access point went down, this access point took over. Okay, so wireless LAN, your lab ends here, and we will move further. So another very important topic, wide area network. What is wide area network, and why do we need it, why do we use it, and how we can use it? Just like a LAN, in a LAN we have one network. Let's say this is a switch. It is connected with the multiple devices. If they want to communicate the other end, we have another switch. For example, this want to send information to this computer, it will go through a locally, which is also known as a LAN. But what in case this portion belongs to USA and this portion belongs to Australia? The same way, this person wants to send the information to this person here, but this time we are located on a different geographical location. To solve this issue, we use WAN, wide area network. And when we talk about wide area network, it means we must have kind of intermediary device or the service provider, which is ISPs, involved. So without ISP, we cannot do the communication between these two geographical areas. So WAN can support many different WAN protocols. When we talk about the WAN, they have different kind of the protocols. Just like we have Ethernet, okay. In under WAN we have PPP, we have HDLC, we have frame relay. Okay, now these days we have MPLS. So these technologies are the part of WAN. So as you can see, WAN can support many different WAN protocols that can help you extend your LAN to other LANs at remote site, connecting company sites together so information can be exchanged. Service providers allow you to lease or share connection that they already have installed. So service provider has, because this is service provider's headache to give you the connectivity between your this head office, your headquarter, to your branch offices. So in between, this is the service provider sitting. So as I mentioned, the most important protocol that is being used in a WAN is HDLC, PPP, frame relay, and ISDN. So as I have already mentioned, why do we need WAN? Basically, when we have this headquarter here, we have some mobile users, we have some telecommuters, we have branch office, we have another telecommuters, and they want to pass information between each other. So that is where we use the WAN. So WAN connects devices located in a different geographical regions. WAN utilized carries such cable companies to communicate across a different geography. So basically these will be the cable companies that will connect this piece with this one, this one with this one, this one with this one. Okay. So WAN utilize various type of serial connections, typically lower bandwidth than LAN, and we know from our experience LAN works at what bandwidth? Initially it was 10, then we have 100, then we have 1000, now we have more than 1010 gig as well. Okay, but opposed to LAN we have WAN, which is typically a very slower bandwidth. Like if we talk about T1 line, which basically works at 1.454 Mbps, megabits per second only. Okay, so the basic idea is the connectivity, means we are not going to send like a bulk information using T1 lines. We will have some kind of relatively very light applications that will be working. Like for example, this mobile user, if want to access this headquarter, he or she will be using a very lightweight applications to access this the resources of these headquarters. Then we have multiple encapsulations, or the terms being used in a WAN. So first thing, in OSI layer, where this WAN falls, as you can see, this is pretty much on data link layer. Frame relay, PPP, HDLC, ATM, these all encapsulation or the protocols works at data link layer. So this is very important part. If I'm talking about uh, in perspective of the questions and answers of the interviews, so they could ask at what layer the PPP or HDLC work, or they even can be more specific, like they can say where WAN protocols being used. So you can answer the data link layer. And what will be at the physical layers, basically the serial connections. So we have multiple solutions that comes under WAN. We have leased lines, we have packet switching, we have circuit switching, metro ethernet, broadband, and what are those things? In lease line, as you can see, when you see a symbol like this, it is a serial link. When you see a straight line, it is Ethernet. So this is serial link, serial connections, and the leased line is dedicated connection. As you can see, this is point to point. We have one router here, we have one router here, and this router belong to ISP. Now ISP has, responsibility how they will reach the other connection, but this is how they're gonna give you a direct link to their routers, basically, with the running of what, either PPP or HDLC as a protocol. So what kind of uh, the speed you are going to get, it is T1, which I mentioned, like 1.54 Mbps when you are using lease lines. Then we have circuit switching. I will talk about packet switching later on. Circuit switching, these are very old technologies. I think you people are not as much older as I am. I do remember when we were using these modem or dial-up connections. Basically, those are connected directly to the PBX, or also known as POTS, plain old telephone systems. Okay, so we have kind of connectivity that basically going directly to the service provider with the help of these ports, and we are connected with that, and we have this predefined link there, predefined connection there. Okay, opposed to circuit switching, and in what technologies we use, like dial-up or the modems, if you are familiar with these things. Under packet switching, and we know when we talked about the routing, what happens in the packet switching. I told you in a circuit switching, this is a predefined path. They cannot take another path. But in a packet switching, we could have multiple paths. We have source here, we have destination here. For example, if source want to send information to this destination, the possibility is maybe it could choose this path, maybe next time when it will come it will choose this path. So it has a variety. So that is known as a packet switching. But when we talk about the WAN packet switching, basically we are talking about the technologies like the frame relays or ATM or X25. In leased line, as you can see, we have point-to-point connection, only two links. But what in case if we have one headquarter which needs to connect with the multiple branches, branch 1, branch 2, branch 3. Okay, so in this fashion, if you are gonna do a lease line like this one here, this one here, this one here, it is gonna cost you so much. So that is where we are gonna use packet switching, which is relevantly much cheaper than the lease line. So in that case, what will happen, we have hub and spokes. These are known as spokes. Okay, then we have service provider that will connect our hub router with these spokes. Okay, if hub wants to communicate with this spoke, it will be like direct communication. But the drawback is that if this spokes wants to communicate with this spoke, means if somebody want to send information to this spoke here, it will always go through hub and then it will come back. So this is a single point of failure. For example, if this hub is down, everything is down. We do not have any kind of reachability. Okay. Then we have Metro Ethernet. I'm not gonna go a lot in detail. As you can see, this is straight line cable. Basically, they're using a kind of layer 2, basically kind of functionality to connect these two branches basically. And then we have a broadband. Broadband is very similar to just like this point to point, but instead of, as you can see, they are using serial connection here, but they are connecting with service provider using DSL modem but Ethernet. So it is some kind of like they want to send information to serial link but with the help of Ethernet, which is known as PPOE, point to point over Ethernet. So this is point to point connection. They want to send information over serial connection but with the help of Ethernet. So if you are familiar with the broadband connections, and if you go inside this broadband router, you will find this PPOE, and they will provide you kind of username and the password. You need to provide that for the authentication purpose. So let's move further. Typical WAN terms. These are very important, vocabularies. Basically, as a professional, you can use it, or when you are working in a production environment, you can use, or even in a interview question, they will be questioned as well. Like WAN, we know what WAN is. Then demarc, and you might be familiar with what demarcation point. So whatever, this is your customer side and this is your service provider. So whatever in between, like the boundary that start from customer or the service provider is known as the demarcation point. The boundary between the customer in-house wiring and the service provider wiring is known as a demarcation point. Then we have CPE, customer premises equipment. So whatever the device is configured at the customer side is known as customer premise equipment. Then we have a local loop and CO that has to do with the service provider end. So local loop is, as you can see, this thing is known as local loop. The wiring running from the demarc to the central office. This is your central office. So whatever the wiring in between demarc and central office is known as local loop. And central office, the point where the local loop gains access to the service provider high-speed trunk lines. This is often referred as a POP or point of presence. So these are the things as central office, or the difference between the CPE or CO. So what are the pieces? Because we just whatever discussed in earlier slides, we talked about like the logically, but we want to see how they physically are connecting with each other. So here's the diagram. Let's say we have one USA office and one is a Europe office. Okay, these are the CPEs, customer equipment, and these are the WAN connections, the service provider basically. We have one CSU, DSU device. This is just like the modem, basically doing the modulation or demodulation, whatever it is receiving from here is converting to WAN. And as you can see, this is the serial link, and this CSU is connected with a serial link with this router, and this router is then connecting with these things, and then similarly here as well. But if you want to see it piece by piece, this is how it will be look like. This is a demarcation point, and behind that we have a service provider, ISP, and from here we CPE starts our customer. Okay, and this is like RJ45 cable, which will be connected with the RJ45 of this CSU DSU device. And I told you what is it. It is basically doing the segregation between our service provider and our LAN environment. Okay, doing modulation, demodulation kind of, if you will. So let's move further. As I mentioned that this RJ45 cable will be connected here. Then this is known as DTE to DCE cable, or also known as V.3.5 cable. Basically provide the clocking or kind of information, you know. So one part of this thing will be connected here. Okay, and this another part which is a serial connection will be connected here. So this is how your CPE customer equipments basically will be connected. But you know, let me be very honest, this is very old technology and it has been obsolete, and it is replaced with what? With this thing, which is known as CSU DSU module WIC 1DSU/T1. Just like this is the WIC card, this is the WIC 2T card. Okay, but it has, if you just zoom in, you will see it has a serial ports. Opposed to that, we have this RJ45 kind of WAN connectors. So what will happen, instead of going through this CSU DSU and then V.35 cable connecting here and there, you will run directly this cable all the way to this module, which will be connected in the router by default. Okay, so this is how your WAN connectivity will be done at on your premises. So since I was talking about that V.35 DTE-DC cable, so I thought that I should add more knowledge and information about that, because you know, this is a very good interview questions and asked in interviews as well. So that's why I have used this slide as well. So you know, as I told you, we have this cable has two parts, which is DTE and DCE. This is known as data termination equipment. This is known as data communication equipment. You can just remember from the C, wherever DCE is involved, it means it is provide clocking. This is my clock, by the way. So it is providing clocking, and clocking is just, for example, the speed. Whereas DTE which is the termination equipment. It is accepting those clockings. Examples like this is the router, or it could be the computer as well. On the other hand, the DCE, which will be in a service provider, this device will be installed in a service provider, while this DTE will be installed in our customer premises. So in our DTE, we know that router or the computer will be our termination points. On the DCE, modem or MUX, which is known as multiplexer. These things will be installed in the service provider. So this is their headache, how they are gonna pass our information to other service provider. But these are the things we need to keep in mind. So this is a cable. It's known as V.35 DTE DC cable, also known as a serial cable. So since we are here on the WAN, so these are the two most important protocols being used in a WAN: HDLC and the PPP. So just for the definition, it is high data link layer control protocol, works at layer 2, used to transmit synchronous data packet between point-to-point nodes. It is a Cisco proprietary, but this is the simplest of all protocol. This is by default. When you connect two Cisco devices or routers together, HDLC will be enabled by default. But what in case if you are using one Cisco device here, and let's say we have one Juniper router here? What are you gonna do? You cannot run HDLC over here. You must have to have the PPP protocol for the compatibility purpose. Okay. So from the definition, it's written that point-to-point protocol is a data link. Also, it's a layer 2 data link protocol used to communicate between two routers directly. The benefit of this PPP has over HDLC, it can provide connection authentication, which means HDLC does not have any kind of authentication. It can do transmission encryption and data compression as well. So if I will do one-to-one comparison, you can see the HDLC is a standard HDLC for the Cisco, whereas this is standard protocol. It can be used with any devices, any vendors. There is no authentication. It uses authentication which is known as PAP or CHAP, password authentication protocols, and challenge handshake protocol basically. Then we have no protocol field here. It has a protocol field here. It doesn't support multiplexing. It's not only support multiplexing but the multi-link as well. Multi-link is just like the ether channel, logical bundling of physical devices as a one. Then it has no error detection. It can monitor and detect the errors. There is no any kind of quality, but it has the quality check with the help of LCP, which is link control. Okay, when we have the connection between two routers with the help of LCP, which is basically just like the heartbeat, it is gonna check the quality. So that's why PPP has so many advantages over HDLC. The only one advantage of HDLC is first of all, this is simple protocol to configure. and it is fast. As I mentioned this one as well, because in CCNA WAN module number 10 covers PPP and HDLC in detail. So whatever I discussed like PAP, CHAP, we will be configuring in CCNA a lot in detail. So this is just Network Pro. That's why, I don't want to make you confused. I will keep things very simple, so you will have a better idea what WAN is, what protocols is. So once you have a little bit understanding, then we will go and dig deep into CCNA modules regarding the WAN technologies. Let's do a demo on HDLC and PPP very quickly on the same Cisco packet tracer as well. So I will close these things first, and from here do a file new. Okay, then click on this network devices, and I'm gonna use 2811 router for that. Drag and drop two routers. So from here select the cable, and I told you it is gonna use what kind of cable? Serial cable. It is not gonna use any kind of Ethernet cable, fast Ethernet or gigabit Ethernet or fiber optic. No. If you mouse over, it's written serial DCE or serial DTE. Okay, you can use either. If you select this one and you try to select, now you do not have any kind of option. If you try to do fast Ethernet 0/0, let's so do it, the cable cannot be connected to that port because fast Ethernet has nothing to do with serial. So what is the solution? You have to add the module in this router. So click on that. First of all, switch it off, and you need to find this module first of all, which should be WIC 2T or WIC 1T. If you want, you can read the detail as well. So very quickly I will drag and drop here and power on this one. Similarly, I will go here, switch it off, drag and drop WIC 2T and switch it on. Now this time when you will select this cable and try to click this one, as you can see we have this serial. Click this one and click this one. I told you one will be a DCE, one will be a DTE. So as you can see here, it is providing clocking, so it means this is a DCE and this is a DTE, because this is a serial cable. For the IP, let's make it like 192.168.100.x network. So this will be 1 and this will be a 2, the host, the IP for this host. So let's very quickly click on this router and just drag and drop somewhere here so we can have a better look of these things. So click on CLI. As you can see, we have initial configuration dialog which we want to ignore just by typing no. Hit enter. We are on user mode. We need to go into enable mode and we need to take a look of interfaces. Show IP interface brief. As you can see, we have serial 030, which is state is currently down and down. this thing is physical. It means if there is no cable attached, it will be down. And this has to do with the link or the protocol. Sorry, this has to do with the link, this has to do with the protocol. Means if the link is up, but what if the protocol is not running, like HDLC is not running, this will be a down. So if these both are down and down, it means not only the cable is down physically, but also the protocol is down. So we need to go into this interface and we will 0/3/0. Then we need to provide the IP. First of all, IP, we said that we will give from the range 192.168.100.1 with the subnet mask 255.255.0. Sorry, and you have to mention IP address as well, ADDRESS, and just do no shut. Okay, so change state to down, and if I do show IP interface brief, it is still down and down because still it didn't get any kind of clocking or any kind of the heartbeat from other. So just save this one by putting WR, come to this router, and we're gonna do the same things but with a different IP. So click on CLI, no, enable, configure terminal mode, interface S0/3/0. This is I am getting from this thing. Okay, so we need to provide IP 192.168.100.2, then subnet mask is 255.255.255.0. Again I forgot address, wow, and do no shut. As soon as I did no shut, as you can see, the links are up. Okay, now this time when I want to see the status, show IP interface brief, you can see both things are up and up. So at this time we should have a happy face because both are working, and from experience I can 100% sure this device can now ping this device. So let's try to ping 192.168.100.1, and as you can see the ping is successful. But we know this is a serial connection and we want to dig a little bit deep about the information. So what we can do, we can go further into detail of this link by providing command show interface serial 0/0/3/0 and hit enter. So it will give me a little bit more information. It will mention that what is the IP and the subnet mask I am using, what is the bandwidth, the delay, which we will discuss a lot in detail when we will hit CCNA. Encapsulation, the most important part. We are using HDLC, which is Cisco proprietary, by the way. Okay, so that's it. It means the by default this is configured. As soon as I connect these two Cisco routers with the help of serial cable, I will get this HDLC. But what in case I want to change this encapsulation? This is very simple. You need to go again into the same interface by using conf t and then go into this interface by typing interface serial 0/3/0 and type in capsulation and hit question mark. You will say currently we can, because we are by default having this one, then we have option configuring PPP as well and frame relay as well. Frame relay, by the way, has been obsolete and even no more is considered the part of CCNA as well. Okay, but still, you know, the teachers are teaching it just for the sake of information, because frame relay is the very simplest encapsulation, and with the help of frame relay we can further move to other technologies, which is like DMVPN. Okay, if you have gone through frame relay, DMVPN will be very simple for you to understand, and I digress here, sorry for that. So encapsulation, we're gonna use what? PPP, and hit enter. That's it. So did you notice something? As soon as I put encapsulation PPP, it means I am using PPP on this router. On the other router I am using HDLC, which is not gonna work. Why? Because these are total different languages. On one router we are saying you are going to communicate PPP. On another router we are saying you are going to communicate HDLC. If I take you to the configuration again, show IP interface brief, as I told you, the physical link is up, is happy, but the logical link or the protocol is down. So this is a very clear indication that physically we are connected, we have heartbeats going on, but we cannot speak the same language. So that is the reason this is down. So this is also one of the very good troubleshooting part as well. So again, if I go into detail of this show interface serial 0/3/0, and now you will see a little bit more as compared to HDLC. So encapsulation is PPP. It uses LCP, link control protocol, to communicate between each other, and it is closed right now. And it uses some other protocols as well, as you can see here: IPCP, CCP, CDP. It has to do with the Cisco Discovery Protocol, by the way, and we will discuss a lot in detail when we will hit CCNA. So this is just for the sake of information. As you can see, there are so many things going on. So it means PPP is much more advanced than HDLC. But you can see serial is up, but the line protocol is down or disabled. So what we need to do, and what is the solution for that? We know that this end is working fine. We have configured the PPP on that, but this is the problem. And how we can check? We can go into show interface for serial 0/3/0, and from here you can see it is still using HDLC, which we need to change. So very quickly we will go into that interface. configure terminal interface serial 0/3/0, and we need to change encapsulation what, PPP. So before we change the encapsulation, I want to ping as well, 192.168.100.2. So as you can see, it is miserably failing. Control C to go back to this prompt and go again, configure terminal interface serial 0/3/0 and change the encapsulation PPP and hit enter. So as soon as I hit this enter, you can see the state is up. You want to verify, show IP interface brief. Now you can clearly see this is up and this is up. So at this time of point, I think we clearly can ping the devices. So very quickly, just ping the other device 192.168.100.2. As you can see, the ping is working fine. So for your HDLC and the PPP, this lab ends here. Let's move back to the slide, and our session for the WAN and wireless LAN ends here. I hope this has been informative to you, and thank you for your time.